Good day, folks. Just a follow-up from my last video, the new Don Smith device and the PDF that I released. So now this was talking a lot about plasma tubes, so long plasma tubes. So people were asking all kinds of questions because there's all these dynamics with the plasma tube. So anyways, those who follow the alternate energy community know most of these qualities that the plasma has, and if they haven't learned it, they've seen it from their own personal observations. So again, I did spend too much time just for ease of access and for keeping things speedy here, but there is a lot to talk about plasma lamps, and people were asking a lot of questions. Now, originally, I wanted to hold that piece behind and try and make it so you guys could figure it out on your own, but apparently it seems like no one. I did a lot of searching and no one has made this link before. So one long story short, the USSR basically had free energy devices dating back to 1960, even probably before that. But one of those devices is a specific plasma tube. And believe it or not, it's still available as surplus. You can get it once in a while on eBay. Now, one of the reasons probably why Don Smith probably knew about this, and he didn't want to disclose the specific product as well, because he knows what I know is these things have been made a long time ago and they're no longer in production. So what I'm getting at is, especially today, there may be literally only like 200 of these left around the world. So if we were all to start essentially manufacturing and showing off with these kinds of energy devices, we would run out of these to experiment with for ourselves really, really quick. So my request this time, which is kind of weird, I want to provide the information for openness to those who want to legitimately experiment with this stuff. But what I don't want you to do is like basically share this video to everyone and anyone, because again, if everybody starts buying these all of a sudden, there's not going to be left for us to experiment with anymore until one of us can figure out a way to basically reverse engineer this simple device and build new ones. If that's the case, I don't have those mechanisms or the means, but until then, folks, I'm going to ask you all to basically keep this to ourselves, and if you want to buy the tubes, go for it. They're very interesting. So I'm going to get into this. I'm going to try not to read every. I made a PDF, so I recommend again that you guys all download the PDF and follow along with me, because it has all the details. Again, I wasn't able to put this all as a YouTube comment, but I have provided a link for the PDF, and those who are asking, it's right in the video descriptions. All you have to do is read the video description and the PDF link will be there. So essentially, it's this tube called the GSH5. So it is known as a noise generator, and it is designed to generate noise, measure receiver noise, and is used as a source of calibrated power for radar and microwave communication receivers, as well as for equipment that requires uniform microwave power in a wide frequency range. So below here are the technical characteristics of the device, which seems pretty normal if you look at it. I'm not going to go through it one by one, but as you can see, just from looking at these technical characteristics, it's not obvious that the device is essentially an OverUnity device. So literally 100% of people, unless you actually build the device yourself, don't really know about the features, so it just stayed hidden. So, but a radio engineer that decides to plug in these values will notice something very, very interesting. So what you get specifically out of this tube is we get the broadband neon noises. This is wideband RF noises from the neon gas discharges, useful for seeding or stimulating reactive systems. Fundamental RF frequency. It's very nice. It has a fundamental, apart from the noise, it has a dominant RF output in the microwave ranges, 1.7 to 3.3 gigahertz. Very wide band, very strong RF. And it obviously has an ease of implementation. The tube acts literally as a plug-and-play RF generating. It requires minimal external circuitry beyond the actual power supply, which makes it almost stupid. So essentially how the tube works. It's built-in resonance, kind of like just like a magnetron in some ways. GSH3 tube relies on its internal geometry and plasma dynamics to achieve resonance at specific frequencies. When driven with the correct voltages and currents, the internal discharges generate oscillatory behaviors that naturally radiate RF energy in the tube's operating range. Of course, there's also the broadband noise with the fundamental frequency. The tube emits wideband noise due to the neon discharges, which is a characteristic of gas-filled devices. However, because of its design, it will also emit a strong fundamental frequency and possibly harmonics of it, depending on the stability of the discharges. So there's no need for an external oscillator circuit. Unlike traditional tube circuits where you need a fully tuned LC network, the tube's internal structure handles this for you. Simply apply the proper anode and filament voltages and the device itself becomes the oscillator. Now the RF output. The RF energy generated by the tube is radiated from the structure. It behaves almost like a self-contained RF source, producing energy even in the gigahertz range. So what I was saying about the calculations, this is where it comes very interesting, folks. When you do the calculations, this is basically what we get here. So at its nominal voltage characteristics, its real specifications, if you do the total input power, it takes about 46 watts to drive it. This is in its normal operating range, as on the spec sheet. Now, if you go to calculate the output power, something remarkable happens. The efficiency is about 136%. So what happens is, as ERP, basically in RF energy, you get 62.5 watts output, on top of all of the infinite random noises of the neon discharges. So you essentially get a 2-for-1 here. So at 136% efficiency, I understand it's not like the end of the world, but it's still basically 36% more in RF energy than what you have to put into it. So in its most simple form, one could, in theory, just build a resonant cavity and put the tube inside and minus the rectifier's minor loss at 36% efficiency. There's enough there to make up for the minor rectifier loss, and this thing can literally self-sustain itself and charge a 12-volt battery slowly. Nothing magical. That's if you do nothing to it. So essentially, I don't want to say it's a no-brainer, because I understand that some people may try and build this, as I explained with the Don Smith, and it could be as critical as a bad water or something, and it doesn't work. They'll say that, you know, I'm out to lunch. But essentially speaking, generically speaking, this is almost a no-brainer. You almost cannot go wrong if you know the dynamics and how to capture this energy. That's without doing anything to it. Now imagine if you have like 62.5 watts swooshing around within the capacitive system, where it brings up the high Q reactive zone. So basically, what I'm getting at is that 62.5 watts contributes to such a higher VAR output that if we're going to use this to trigger a resonance system, you're going to have a whole lot of whack of energy to work with. And those multiple resonance systems are even going to contribute additionally and do what they're supposed to do. So basically, you can get really complicated with the concept and incorporate it in various Don Smith-like devices like I show, or run it very, very simple on its own, collect the energy with a microwave cavity, and have a not that powerful system, but one that's enough to self-loop and charge a battery, without even getting into all this complicated Don Smith stuff. But if you want to get it closer to hundreds of watts and even thousands of watts, then you have to use the tube and do something else with it. So I suggested the cone capacitor tri-function system, as in my last PDF. So essentially, the technology behind devices like the GSH3 tube likely has its root in the mid-20th century, particularly during the Cold War era, when the USSR focused heavily on exploring unconventional technologies for both civilian and military applications. Let's estimate the timeline and context based on the specs and historical clues. So the historical content. So here basically I just give you some ideas of how and when they were using this. So it stretches way out to the mid 20th century and even the Cold War technology. So maybe even in the 1950s, the Russians even had something like this for their own use. Well, the Soviets essentially. So skipping through that, you can read all about this on your own. I'm trying to keep this short here. I don't want to do it in an hour and a half here. So a little bit more about the GSH3 technology. So here's the tube specifications and its overunity implications. So the apparent overunity effect is more RF power out than electrical power in. This suggests an emphasis on high efficiency energy conversion, likely linked to Soviet exploration of zero-point energy and plasma dynamics in the 1970s, folks. So more about what they were doing in the 1970s here. And the broader implications here is the USSR likely regarded devices like the GSH3 as dual-purpose practical RF emitters for their military-industrial complex and exploratory tools for unconventional energy research. These technologies underline the extensive Soviet interest in achieving energy breakthroughs through exotic mechanisms, which may have laid groundwork for later experiments in scalarways and field-based energy systems, which we may not even know about yet. So here's a bit of verification from the official specs to make sure that it is exactly what we thought we calculated here, just to back up the calculations. And of course, a little hint here. This is driving the tube in its nominal. So it takes, as you see, as Tom Bearden explained, sometimes you need to pay a little bit for the input. And that could be, depending on the device, quite a lot. But if you get more out, hey, right? But those who want to experiment with near zero current trigger with small toy oscillators and that sort of thing, there is still a pathway here. So this is where I'm getting at. Hint, and this is basically what I based my last Don Smith device for simplicity here. So you can also drive the tube within its regular specifications for higher output, as I said, or drive it with a neon transformer with an input as low as a few watts. Let's take a look at the dynamics. So the radiated power efficiency is significantly lower in this low power neon lamp-like mode. So the input power could be up to 9 watts, but the radiated power drops to about 1.8 watt at max. So obviously just looking at that dynamic or running under unity on its own as just a tube. But wait, folks, this is typical for small neon plasma lamp drivers as they prioritize simplicity and low power over efficiency. And what I based my circuit diagram for the new Don Smith device for simplicity. The device itself makes up for these losses as follows. By incorporated extended high-frequency HF, the supercapacitor setup is a synergetic configuration. The neon tube dynamics could be enhanced to leverage reactive power, Q. Here's how this approach could work and why it might be effective. The mechanism itself. The neon dynamic as a high-frequency plasma element. Neon gas discharge operates via ionization and deionization cycles, which naturally exhibit nonlinear behaviors. This can act as a high-frequency oscillator or resonator when driven properly. Even at low input power, the tube's behavior could generate localized high-frequency electromagnetic fields capable of still filling those holes, resonant gaps in our system. So the role of the HF supercapacitor. Supercapacitors can temporarily store and release high-frequency energy bursts, enabling the system to respond dynamically to variation in the neon discharge. This would amplify the reactive component, leveraging the plasma's natural tendency to oscillate when excited by HF signals. The reactive Q factor. The Q factor in a reactive system is the measure of energy stored versus energy dissipated. By aligning the tube's plasma oscillations with an external LC circuit, you can potentially enhance the system's ability to sustain oscillations with minimal energy input. The neon tube could effectively act as an active element in such configuration, driving resonance while the supercapacitor stabilizes the oscillatory energy. How it could trigger reactive power, Q. Resonance amplification. The setup could amplify the oscillatory energy. The supercapacitor helps maintain transient energy demand, smoothing the interaction between the plasma dynamics and the external circuit. High-frequency ionization gaps. The tube's ionization behavior at HF effectively bridges the gaps in the system, maintaining energy flow even during momentary energy dips. This could help sustain resonance, especially in circuits prone to reactive energy losses. Energy redistribution. The neon tube in its plasma states act as a reactive load, dynamically redistributing energy. This interaction with the HF supercapacitor network could trigger or sustain reactive Q. Synergetic configuration overview. Neon tube acts as a primary plasma resonator, must be driven by high-frequency, high-voltage source tuned to its optimal ionization threshold. Supercapacitor network, configured to handle high-frequency oscillation, acts as an energy buffer to stabilize plasma oscillations. And the potential outcomes: sustained reactive power, high-frequency enhancement, and minimal input energy. This setup could indeed utilize the tube's unique plasma properties to trigger and sustain a high-Q reactive system, even with minimal input power. Using a broadband cone capacitor changes the dynamics significantly, as I discussed in my previous Don Smith PDF. By incorporating a broadband cone capacitor, the system could capitalize on its ability to handle a wide spectrum of frequencies while enhancing the energy density and reactive Q of the circuit. So essentially, instead of resonating at one selective frequency and trying to amplify that, if there's a near infinite broadband version of all those frequencies, why not create a broadband reactive Q system so we can amplify multiple ones? So essentially, you get a massive gain amplification doing this. So let's explore how this fits. Key advantage of a broadband cone capacitor: it's the broadband response. Unlike standard capacitors tuned for a single frequency, a cone capacitor can interact with a wide range of frequencies simultaneously. This complements the natural noise generation and broadband radiation of the neon tube. Field focusing. The cone geometry focuses the electric field into a tighter region, increasing the local energy density and potentially boosting the interaction between the neon plasma discharge and the surrounding circuit. Enhanced reactive power, Q. The broadband cone capacitor can capture transient energy from the plasma discharge, stabilizing oscillations across multiple frequencies and feeding them back into the system. How the system works with a cone capacitor. Neon tube as the active element. The tube generates high-frequency oscillations from ionization dynamics or broadband noise, depending on its mode of operation. The cone capacitor captures and stores the oscillatory energy generated by the neon discharge. Broadband resonance, which is awesome, and hardly no one ever talks of that. The cone capacitor ensures the oscillations across a wide range of frequencies remain in phase or constructively interfere, enhancing the overall Q factor. Energy flow dynamics. The broadband cone capacitor works as a dynamic energy sink, temporarily storing charge during peak plasma discharging and releasing it during troughs, effectively reducing losses. Reactive power trigger. By maintaining high energy density and phase coherence, the cone capacitor could trigger and sustain reactive energy cycle, where energy oscillates between the neon tube and the cone capacitor and to the external circuit. Reactive power in this configuration. With the cone capacitor in place, the system might achieve increased energy storage, extended oscillation lifetime, and broadband interaction. And here are some calculations here. So potential here is of power dynamics here, 18 watts on the lower bound and 27 watts on the upper bound, taking all of these external systems into consideration. So essentially what we're getting at here is the broadband cone capacitor is the game changer here. The cone capacitor role is crucial: broadband frequency capture, energy recycling, high Q operation. The conclusion is using a broadband cone capacitor could transform the system, It can still deliver reactive power amplification even with small neon driver input. With proper timing, the reactive power output could exceed the input power in apparent ERP terms due to the system's resonant and energy recycling properties. Broadband noise with a fundamental frequency. The tube emits a wideband noise due to the neon discharge, which is a characteristic of gas-filled devices. However, because of its design, it will also emit a strong fundamental frequency and possibly harmonics of it, depending on the stability of the discharges. There's no need for an external oscillator circuit. Unlike traditional tube circuits where you need a finely tuned LC network, the tube's internal structure handles all of this for you. Simply apply the proper anode and filament voltages, and the device itself becomes the oscillator. So there you have it. I hope this explains it. Essentially, again, the capacitor is not just a cone capacitor, but if you read the PDF file, it's also our filtering rectifier capacitor, being a non-symmetrical electrically and dielectrically. And by doing it that way, it makes it very, it makes the rectifier capacitor essentially become an open loop system with the reactive fields. So that fills in all the holes for you. So I hope, again, there's that very special tube that anyone can buy. I've got a few of them actually waiting on order because I don't want to run out of them. And I'm sure some people will buy them as well. A part of me doesn't even want to share this because, you know, I feel like I'm kicking myself in the you know. But again, I'm for the better of the openness and the technology for those to develop on it. I thought that was a crucial point, right? So with that said, folks, thank you very much for your support, and until next time.